In 1978, if you were lucky enough to have $440 to purchase a piece of audio gear and you needed a power amplifier, you could have purchased this Marantz Model 170DC power amplifier. And in case you're wondering, that's about $2,100 in $25. The 170DC was rated at 86 watts per channel into 8 ohms, both channels driven, at not more than 0.03% THD, and it weighs about 35 pounds. Now there is a companion preamplifier for it, the Model 3250B Control Center preamp, and that video will be following this one next week, so that's looking forward. But this video is going to focus on the power amp, and of course I'll do a tour of the front, the back, pop the cover off, and talk about what it looks like. And then of course I'll tell you how it performed on the bench. And there's not going to really be much of a discussion about its listening test because I want to hook at the preamp and the power amp up together and see how they sound. Although I did do a short listening test to just this guy. So that's kind of what's coming up. As far as to how I got these, my good buddy Ian was considering trading his Pioneer HPM 100s, the Super Tweeter is not working on either one of them, for this Marantz pair. And there's a customer of his was interested in the HPM 100s, and he can't hear past 18 kilohertz, so it's not a problem that the Super Tweeters don't work. Ian wanted me to go ahead and check out this pair for him. He was having some difficulty with the preamplifier, and so he brought it to me, and I checked stuff out for him. So that's how come I got these to show to you folks. So let's get on with the tour. Here is a close-up view of the Marantz 170DC. I'm going to go ahead and plug it in, and hopefully you'll be able to hear the speaker protect relay come on, and then you'll see the display light up. Hopefully you heard the speaker relays come on. We'll start over here with the gain control. So you have one for the left, one for the right. You could get a little bit more than 24.5 dB, which is where I did my testing. Maybe 25 dB at the most you could get out of the amplifier. And hopefully the blue and red sections of the power meters are lighting up well enough to be seen in this video. You also have the 2 peak LEDs. Now when I was testing for the 4 ohm max power, they did come on when I was hitting probably 6/7% THD at 1 kilohertz, so they do appear to work. As you can see, the 0 dB reference point is at 85 watts. Overall, I think it has a very nice look to it. Now, the only nitpick I have on this unit is that there is no on-off switch. When we look around back, you'll see there's no power on-off switch. I believe that it was designed to be plugged into the switched outlet of the matching preamplifier, but other than not having a separate on-off switch, I'd say it has, a lot of nice features for a power amplifier. This obviously is the rear of the 170DC power amplifier. Starting on the left, we have 2 AC outlets, and they're both unswitched. We have a user replaceable fuse here. Then we have the standard push in the wire kind of speaker connectors for your left and right speakers. We do have something a little unusual in that we can choose between DC coupling or AC coupling, and then of course our RCA inputs are right there. One thing I wanted to point out is that this particular 170DC has a custom case. Maybe the wooden case that it had an option for, or the metal case was destroyed, and the owner at one time had a custom metal piece made for it. It's very well ventilated, and you can kind of just see that it looks okay. It does the job. It's just not stock. Here is our standard THD SNR plot at 1 kilohertz with the 170 DC putting out about 5 watts into 8 ohm loads. The volume controls for each channel, or the gain controls, have been set for about 24.5 dB. You can see our THD is better than the spec limit, although that's a full power spec limit of 0.03%, and our SNRs are right around 89 dB, we'll say. Right now we've got a 1 kilohertz signal going into the 170 DC, and we're hooked up to 4 ohm loads and putting out about 5 watts into those 4 ohm loads. The gains or the volume controls have been adjusted a little bit different. They're right around at 24 dB instead of 24.5 dB. If you compare this with the 8 ohm load case, you can see the THDs are fairly close to what they were in the 8 ohm load case. The SNRs are down 8, 9, 10 dB depending on which channel, and the THD plus noise is a little worse when it's hooked up to the 4 ohm loads, at least for the left channel. For the right channel, it's a few dB better. With the 170 DC putting out 86 watts into 8 ohms, we're supposed to be able to be at better than 0.03% THD. Well, we're putting out, we'll call it 89 watts into 8 ohms. The THD, at least for the right channel, is we'll call it 0.1%, and the left channel is 0.2%. So it's not meeting that requirement. It's still pretty decent considering the age of this guy. SNR is better than 74 dB, and this is with the volume control set for 24.5 dB of gain. Our THD plus noise, nothing stellar about this, 50 minus 56 minus 60 dB. So, you know, it's looking okay overall. I would say it's not the cleanest amp in the world, but it looks like it's fairly original from what I can tell. And in case you were wondering what the harmonics look like with it putting out, in this case I backed down the power just a tad, 87 watts into 8 ohm loads. You can see that our even harmonics right here are either higher or lower than the odd harmonics. It's kind of a mixed bag. The left odd harmonic is higher than the left even harmonic, but the right even harmonic is higher than the left odd harmonic. So it's kind of a mixed bag. See that every now and then. With 4 ohm loads connected, I was able to get 154 watts out of the left channel, and the right channel was 149 watts. The THD for the right channel is meeting the specification, which was 0.09% into 4 ohm loads. There was no power specification into 4 ohm loads, just a THD. The right channel's off a bit, but 0.34% is really not that bad. SNR is much better for the right channel than the left channel. And let me just get rid of the left channel for a moment, and you can see how much nicer the harmonics and such looks for the right channel. Now, I stopped trying to get more power out once the peak LED came on for the left channel. I figured 154 watts was probably good enough. And I probably could have got a little bit more out of the right channel, but once the peak LED came on, I figured it was good enough. Here's the 170 DC's gain from 20 hertz to 20 kilohertz, with it putting out about 5 watts into 8 ohm loads. From this, we can get the frequency response. And basically, the spec says it should be plus or minus 0.2 dB over that frequency range. If we use 24.3 as the normal, we would be up 0.2 of a dB, would be 24.5. We're meeting that requirement. And then we would be down as far as 24.1, and we're meeting that requirement. So we are hitting the specification for frequency response. Here is the 170 DC's frequency response, with it putting out about 5 watts into 4 ohm loads from 20 hertz to 20 kilohertz. Actually, it's showing the gain, and we'll look at the frequency response. We'll just pick 24.1, and the specification is that it should be plus or minus 0.2 dB. So that would allow us to get up to 24.3. We're good there, and down to 23.9, which would be right here. And at the very high end of the band, we're down a little bit more than that at 23.7. It's still pretty good, although it's not being the plus or minus 0.2 dB. It's maybe plus and minus 0.4 dB, something like that. But overall, I would say it's very good. It is not as good as it was looking into 8 ohm loads. Here is the 170 DC's damping factor from, in this case, about 28 hertz to 20 kilohertz. The specification is that the very low end of the band, it should be at least 60, and we're depending on the channel, we're not quite even half of that here at the low part of the band. So it's not meeting its specification for damping factor. This plot shows the Marantz 170DC's THD versus frequency for several different output power levels, and that would be into 8 ohm loads. Once again, I'm using the direct coupled input, and I doubt there would be any difference if you use the capacitive coupled input. Frequency range, of course, is 20 hertz to 20 kilohertz. The specification is that at full power, it should be better than 0.03% THD, which would be around here. So we are failing that at the very high power levels at 80 watts, at least with the left channel. But the worst case THD is 1%. At 80 watts for the left channel, and the right channel, the thicker blue line right here, is better than that. So overall, I would say the majority of the THDs are better than probably 0.0203% across the band, which is still pretty good considering the age of this amplifier. Right now we're looking at the 170DC's crosstalk from 20 hertz to 20 kilohertz with the active channel, putting out 5 watts into 8 ohm loads. Now, the specification varies a little bit on the frequency, but we'll just say that it should be better than 55 dB. So our right to left crosstalk is meeting it, and we're just a little shy here at 52 dB for the left to right crosstalk. Here is the 170DC's multitone response. And we'll look at the left channel first, and it shows a distortion free range of between about 9 to 11 bits. If I bring up the right channel, get rid of the left, the right channel is a bit better, and I would say the distortion free range is 11 to 12 bits, and this is into 8 ohm loads. Right now we're looking at the Marantz's intermodulation distortion, and for this test we're using a 60 hertz tone and a 7 kilohertz tone, and the 60 hertz tone is 4 times larger than the 7 kilohertz tone. Now the specification is that the IM distortion should be better than 0.03%, and for the left channel we're at 0.04%, that's pretty close, and for the right channel we're at 0.0264%, so it's a bit better than 0.03%. Right now we're looking at the system noise of the 170DC amplifier with the inputs terminated into shorts, and the gain for both channels is set to 24.5 dB or so. This is showing some power supply noise spikes here at 60 hertz and 120 hertz. And when I have this moved over to the Wilson Watt 3 Puppy 2 loudspeakers, I'm going to hear a little bit of hiss and hum. Right now we're looking at the difference in phase at 1 kilohertz between a signal going into the auxiliary input and coming out of the right channel output in this case, which is an 8 ohm load. And at 1 kilohertz there is no difference in phase. At 100 hertz, there still is really no difference in phase. However, at 10 kilohertz, we have about 6 or 7 degrees phase change between the input signal and the amplified signal. There is no specification for the rise time, but it's being measured as 2.46 microseconds. And finally, between the left and right channels at 10 kilohertz, there is no phase difference with the same signal applied to each of them. I thought this particular Marantz model 170DC power amplifier did an okay job of coming close to its performance requirements. In some cases it did better than the specifications, but it was usually a little under, although it had no trouble putting out the output power of 86 watts into 8 ohm loads, and into 4 ohm loads it was not quite double, but a fair amount of output power at less than, we'll say, 1% THD. Actually much better than that, maybe 0.5% at the real high power levels. But overall, I thought it performed rather well. I think it's got a very nice look to it. I kind of like the champagne gold color, and the meters with the blue and the red just kind of look really nice. And you know, it's just a piece of classic Marantz gear, I would say. And overall, I thought it did a really good job. It wasn't as noisy as the data showed when I connected it to the loudspeakers, the Wilson Watt 3 Puppy 2s, and terminated the inputs with the volume control set for 24.5 dB of gain. I barely heard any hiss at all out of the left channel. The right channel, I didn't hear anything, and I was right next to it. My ear was right next to the speakers, and so if you moved away a foot, you wouldn't hear anything out of the left channel. But the left channel had a few more issues. From looking at the tour pictures, you can see there's a lot more heatsink grease around the output transistors. Plus it said OK written on the one transistor. So I think at some point in time the output transistors were replaced. They are the same type as what are on the right channel, so I'm not sure when that was done. It looks like it was done a long time ago. There is only one adjustment for the amplifier as far as the output devices, and that's the DC offset, and they were both set for pretty close to 0 millivolts. Now the power meters I did adjust, and there is a procedure for that which is wrong in the manual. So if you have one of these and you want to adjust the power meters, you turn all of the 4 pots counterclockwise to start with, and then the pots that are labeled 11 and 12 are really 1 and 2. So if you do that, you can follow the procedure and adjust it. And one thing I was struggling with after I did the procedure was the power meters were not accurate. Maybe I could get them accurate at one power level, and it kind of bothered me a little bit. I just couldn't get it. So I decided to download the owner's manual because I was curious about the clipping indicators, and it turns out in the owner's manual it states that if you were using the power meters to look at the power of sine waves, they're not going to be accurate. So I'm not sure what's up with that, but I wish I would have read that to start. It would have saved me a bit of time of going back and forth and researching how to do the calibration, which there was somebody who had explained about the typos in the owner's manual about that power meter calibration. Anyway, when I used it for my little listening test, they seemed to move just fine. I didn't really compare them to any other power meters I have as far as accuracy, but I did do the procedure as described in the service manual for the power meter. So that being said, I think it's a nice looking unit, and when I finish the review on the preamplifier, I will hook them both together and kind of do a review of the total sound of those. But just a little bit of listening I did, it sounded just fine. I used my Carver C1 as the preamp for it, and it sounded just fine. I didn't really have any complaints about it whatsoever. It does what a power amplifier should do. Now, one new test that I'm going to start doing on these, I don't really have like a graph or anything. It's just a measurement that I do, and that is the dynamic headroom. And in this case, it is 1.8 dB, and that's a test where you measure the rated output power. So you would look at the power at 86 watts into 8 ohms, and then you look at the power level with a very short 1 kilohertz burst. It's about 480 milliseconds long, and it starts down 20 dB. Oh, anyway, it's a standard that was more predominant in the older days of amplifier specs. This did not have that specified for headroom, but certain amps have it, and I thought it's a fun thing to measure. So this one was 1.8 dB, which kind of means that it has the ability to rise up to meet peak music demands, maybe better than, say, an amp that had half a dB of headroom before it starts clipping. So that's kind of where that spec comes in. So anyway, I will start measuring that on amplifiers in the future, or it's possible by the time you see this video there may have been an amplifier where I measured it. I'm not sure where this is in queue with the stuff that is measured, but anyway, in case what happens before, that's what's going on with that measurement. So that's kind of my take on the Marantz 170DC power amplifier. Once again, if you have any questions or comments, I look forward to seeing those in the appropriate section. And please give me a thumbs up if you liked the video, and if you have not subscribed, I hope you'll consider doing that to help the channel grow. So once again, until next time, I hope you'll have a great day or night.